This is our first problem for isothermal processes. Please take your time to read and understand the problem. The problem gives the initial volume, pressure, and temperature of the gas inside the piston cylinder device. The working fluid inside our device is stated to be air. We are also given the final volume of air to be equal to 0.1 cubic meter. Now, since the temperature of the air remains constant during the compression process, then we can say that air undergoes an isothermal compression process. This means that the final temperature of the air is just equal to the initial temperature, which is equal to 353 Kelvin. From this given information, we shall find the non-flow work and the amount of heat transferred in kilojoules and the change in entropy in kilojoules per Kelvin. Now, before we proceed with the solution, we shall be sketching the PV and TS diagrams. Based on the given, we know that air underwent a compression process. So between the PV and TS diagrams, it is definitely easier to sketch the PV diagram first, since we know that the PV curve during a compression process starts from the lower right and ends at the upper left. Now the direction of the TS curve will just be similar to the direction of the PV diagram. Since we have an isothermal process, our TS curve will be a horizontal line which starts from the right at state 1 and ends at the left at state 2. Now let's solve for the non-flow work. W sub n can be solved using the formula that we derived in the previous lecture video. Substituting all known values in the formula, we will get negative 55.4 kilojoules as the value of the non-flow work. Next, we solve for the amount of heat transferred. Since we know that heat is just equal to the non-flow work during an isothermal process, then Q will also be negative 55.4 kilojoules. Finally, we shall solve for the change in entropy during a compression process. We know that the change in entropy can be computed using this equation, which is based on the TS diagram. But we no longer need to evaluate this integral, since we already know the heat transfer during the process. So by substituting negative 55.4 kilojoules for heat and 353 Kelvin for the temperature, we'll finally get the change in entropy during the compression process. Now let's check the sign of the answers that we have just computed. All these quantities are negative and their signs are consistent with the direction of the curves in the PV and TS diagrams. Remember that when the PV diagram goes from right to left, then the non-flow work should be negative. On the other hand, when the TS diagram goes from right to left, then the heat transferred during the process and the corresponding change in entropy should be both negative.